Hi, I'm Dick Taylor, 20-year owner-operator. In fact, I used to drive this truck. Today we use it to develop the first prototype for a system that we call Green-Aire. It's the first of its kind to use the truck's OEM air conditioning system to operate while the engine's shut down. Now, a few years ago, we were talking about how we might improve over auxiliary power units and their associated costs for acquisition and to maintain. And we asked ourselves if it was possible to operate the OEM air conditioner with the engine shut down. As you're about to see, it can be done. So the first problem we faced was how to drive the compressor with the main engine shut down. And what we did first is remove the alternator and build in this 12-volt brushless DC motor generator. The second problem we faced was how to free up the belts. So we removed this auxiliary drive from this Detroit Series 60 engine, and we replaced it with a custom-made auxiliary drive like this one. And the way it's designed, it has two grooves cut to match the alignment of the original belts, but instead of being fixed, it's free to turn while the engine's shut down. The next problem we faced was how to cool the refrigerant without a fan. And as you can see in the beginning of this film, we installed a fan shroud with four 12-volt DC fans that actually work probably better than the big fan does. The next problem we faced was how to supply auxiliary energy to the motor generator. And that was actually the simplest. What we did was mounted four truck batteries in parallel on a separate circuit to supply energy to the motor generator. Now the two circuits, the one for when the big truck is running and the one when the big truck engine is stopped, is controlled through this switch. On one, the big motor is running and the motor generator is operating as a generator, and it comes through this energy management system that we made and installed underneath the sleeper berth. And what it does is supplies energy to all 7 batteries, but still keeps the two circuits separated. All right. So now we're going to switch over to circuit 2, and you'll get a look at how this operates with the engine shut down. All right, now go on up there. I'm going to shut this back off. Do it. So as you can see by the stationary crank belts, the engine is now shut off, and yet the compressor is running under power of this 12-volt DC motor. And that's down probably to about 40 degrees right there. I had to stop and write down some notes for the last segment of this video, so please bear with me. We need you to know why we did this project, how it compares with other APU or auxiliary power units, where we are in the project, and where we'd like to go from here. We decided to proceed with this project with the owner-operator and the small fleet owner in mind. We wanted a design that was lighter, cheaper, and simpler than the auxiliary power unit. The prototype you've seen is for the Detroit Series 60. However, we have other designs that will accommodate most Class 8 truck engines. Our system uses no fossil fuel in order for it to work, and it requires a negligible parasitic load on the engine while the truck's going down the road to store energy in the system. Anyone with a set of hand tools and a multimeter can work on just about anything that we install in this system. It's a non-intrusive and fairly easy to install unit. You don't have to cut holes in the cab or the sleeper or the fuel tank in order to use it. And most of the components of the system are already on your truck, like the compressor, the refrigerant lines, the refrigerant, the evaporator, the expansion valve, the condenser, and the sleeper berth blower and controller. It doesn't need carb testing for approval because it has no emissions, and the same is true with the EPA. All the wetted parts are already on the truck when it comes from the manufacturer. All we're doing is finding a way to drive it with electricity. We think the final design should be cheap enough to pay for itself and put about 10 grand in the owner-operator's pocket before the warranty expires. Now here's where we are now. We have a working prototype, as you've seen. We have a patent with 17 claims granted. We have a patent pending on some refinements that we did to it. And Steve Breyer, Paul Harris, and I have a 100% equity in the project with no business arrangements with any person or any other company. There is no debt, no encumbrance, no suit against this project. And probably most importantly, there is no government entity involved in or even aware of this project. Now here's where we'd like to go. First, we need feedback from you on what you think of the merits of this project. If you or someone you know has a product or an idea that you think would make this a better product, we'd like to hear from you. You can leave your comments down below on YouTube, or we'll give you another way to contact us. If you looked at this system and you think you can make it commercially successful, and you have the business savvy, the technical savvy, and the financial resources, you can take this project over. You can relocate the truck to your shops. We'll provide you with whatever you need of the approximate 4 gigs of SolidWorks and Mastercam drawings that we made. We'll be available for consultation here, and we'll negotiate a substantial equity stake in the project. If you want to contact us, you can go to our website, which is www.Green-Aire, that's GREEN-AIRE.com. And I want to thank you again for watching this video, and we're looking forward to your responses.